Now today we are discussing one of the topics in Form 4 syllabus, longitude and latitude, which is highly said. Now, as you know that the Earth, let's start with the introduction. As in the Earth, you know that Earth is spherical in nature. Earth is spherical in nature, and it has some imaginary lines. Now, these imaginary lines are what we will discuss today, like imaginary lines. Now these imaginary lines, these lines which run from north to south are what we call the longitudes, and the lines that run from east to west are what we call the latitudes. Now latitudes, we have the main latitude, the main longitude, which is called the prime meridian. Prime meridian is always 0 degrees. It's marked 0 degrees. Now the remaining longitudes are always marked west or east of the prime meridian. Then the main latitude is called the equator, and equator is also 0 degrees. And the remaining latitudes are marked north or south of the equator. Any latitude to the north is given in the north in the degrees north. Then any longitude which is in the any latitude which is in the south is given in the degrees south. Then any longitude which is to the west is given in degrees west. Then any longitude which is in the east is given in degrees east. Now this is, in simple terms, these are the longitudes and latitudes. Now next thing we want to discuss here is what we call a great circle. We want to know what is a great circle and a small circle in terms of longitude, and a small circle in terms of the longitudes. Now, what is a great circle? A great circle is a circle formed by any longitude or latitude. A great circle is a circle formed with the radius equal to the radius of the Earth. Now, a circle which is formed with the radius which is equal to the radius of the Earth. The radius of the Earth is only 6370 kilometers. Now, any circle which is formed on the Earth's surface which has the radius which is equal to 6370 kilometers is said to be a great circle. Now, is said to be a great circle. Now, all longitudes are great circle. They form a great circle because if you look at the longitude, if you come across this longitude here, you go along this longitude here, you will find that it will divide the Earth into two equal parts. Therefore, the radius of this longitude here will be 6370, which is the same as the radius of the Earth. Then we have the small circle. What is a small circle? A small circle is a circle which is formed when the radius of the Earth is smaller than the radius, whose radius is smaller than that of the Earth, Now, the small circles are always the latitudes. Then almost all the latitudes forms a small circle except the equator. If you look at the equator here also divides the Earth into two equal parts, meaning its radius is the same to the radius of the Earth. But other latitudes like this, I see this latitude here, the radius is not equal to that one of the Earth, and this one here, the radius is not equal to that one of the Earth. Now, all latitudes are found to be along the small circle. All of them are found to be along the small circle, except the equator, which is said to be at along the great circle because it divides the Earth into two equal parts. Now, having discussed the great circle and the small circle, the next thing we want to discuss is the position of places. Position of places on the Earth's surface. Position of places on the Earth's surface. Now, how do we get a position? Position on the Earth's surface is given in a pair coordinate form. They are always in a pair coordinate form of latitude, comma longitude. A pair coordinate form of latitude, comma longitude. For example, if I have, let me assume this is my globe. Let me assume this is my globe. Then that is my prime meridian. Let me assume that is my prime meridian. That is my equator. Then there is a longitude that way. Then this is the equator, which is 0 degrees. And this is a longitude. Let me say this longitude is 45 degrees west. Then there is a place at this point here. There is a place at that point. Now we say that place, let me say this is a place P. Now the position of place P is given by the pair of latitude, longitude. Now the latitude here is 0 degrees. 0 degrees neither west nor east. Now we say it is just 0 degrees and 45 degrees west. That is the position. The position must be in a pair coordinate of latitude, longitude. Now let me say another one is this one. Is this one here. This is another position here, which is along the prime meridian, which is found in the prime meridian, and a latitude, let me say 35 degrees south. Now to get that position, let me mark this position to be position even W, position W. Now position W is given in form of latitude, longitude, which is 35 degrees south, comma 0 degrees. Now you can see how we get the position of places on the Earth's surface. Position of places on the Earth's surface. Position is given in form of coordinate form, which is in form of latitude, that is a latitude, and longitude. Now that is very good example how we get the positions. Then the next part we are going to deal with the distances along the Earth's surface. Distances along the Earth's surface. Along the Earth's surface. Distances along the Earth's surface. Distances along the Earth's surface. Now, under distances along the Earth's surface, we have distances which are along a great circle. Distances along a great circle. And the distances along a small circle. Along the small circle. And all these distances can be in kilometers or nautical miles. Kilometers or nautical miles for the level. Now we want to discuss these distances in kilometers or nautical miles along the great circle or along the small circle. Now, if you look, for example, I want a distance along the longitude 45 degrees west. I want a distance along the longitude 45 degrees west. A longitude is something like this. It looks something like this. Then there is that prime meridian. Now it forms an angle. It forms an angle. It seems to be it forms an angle to the prime meridian, to the center of the Earth. Meaning it forms an angle of 45 degrees at that point. Then it's that. Now if you want to find the distance from this part up to this part, it is always the arc length. And you know the formula of finding the arc length. The formula of finding the arc length is said to be theta over 360 2 pi r. Now this formula here do work when it is along the great circle, when the radius of the Earth, when the distance formed makes a radius which is the same to that radius of the Earth, where this radius here to be 63.7. Now that means the distances along the great circle. Distances along the great circle is given by the formula theta over 360 2 pi r. That one is in kilometers. But it is also said that 1 degree is equal to 60 nautical miles. That means to get the distance in nautical miles, I will take theta times 60. That one is along the great circle, when the distances are along the great circles. Now, distances along the great circles in kilometers, we have theta over 360 2 pi r, where r is the radius of the earth. Then, distances along the great circles in nautical mile is given as 60, is given by theta by times 60. Then, distances along the small circle. Distance along the small circles is given by theta over 360 2 pi r cos alpha. Now, because I said that the small circles has a radius which is different, which is smaller than that one on the earth. And if you look at this radius, it's the radius of the earth. Now that means when I take this radius, then I multiply to the cos of alpha, then I'll get the small radius of the earth, the small radius of that one, of that earth. That means the distance is always theta over 360 2 pi r, small r, of which this small r is always the same as r cos alpha. Then the distance in nautical miles is given as theta times 60 cos alpha. Though these are the formulas that we are going to use, and we are going to know where theta comes from and where we have our alpha coming from. Now those are the formulas we are going to use on finding the distances on the earth surface. That's in a great circle, and this one being in a small circle. Now in other distances on the earth surface, we have some of examples. We have some examples. Let us do some of the examples for us to know where theta and alpha comes from and how we can calculate them. We have example 1. Find the distance between points. Find the distance between point P 40 degrees, which is given in 40 degrees north, 50 degrees east, and Q, which is given in 20 degrees 30 minutes south, and 50 degrees east. Part A in nautical miles and part B in kilometers. We want to find that distances. Let's find the distance between point P 40 degrees north, 50 degrees east, and Q 20 degrees, that is 30 minutes south, and 50 degrees east. Now if you look here, we have introduced something called minutes, and it is said that always 1 minute, 60 minutes is given to be 60 minutes is always equal to 1 degree. Now it means we have to change all of these things into degrees. Now 60 minutes is equal to 1 degree. Therefore, 30 minutes is equal to what? That I'll get it to be 0.5 degrees. Then this 0.5 degrees I add to this. Now this part will be 20.5 degrees south. Now that is the position in degrees, 20.5 degrees south and 50 degrees east. Now we want to calculate the distances. First of all, we need to know this distance, is it along a great circle or is it along the small circle? You can even look at it and see and know, because if it is along the same longitude, look here, the longitude is the same, the distance is along the longitude, it is the same, but it's only changing the latitude. That means it is along the great circle, it is along the longitude. If you look at the globe, let me just draw it. Look, the globe, I will draw the two positions. This is the prime meridian. Between the two positions, this is the equator. Now, position of point P is given 40 degrees north, 50 degrees east. Now, let me say this is my 50 degrees east, longitude, 50 degrees east, then 40 degrees north, 40 degrees north. This is 40 degrees north. Then it is found here. This is where we have point P. Then point Q is 20.5 degrees south. Point Q is 20.5 degrees south. Let me say it is here, 20.5 degrees south. Then 50 degrees east, meaning it is here. If you look this distance here, they want this distance here. That distance there, they want it. They want this distance here. Distance P to Q. They want that. If you look at that distance, it is along a longitude, which means I say all the longitude, all distances along the longitude are the great circle. That means to get this distance in kilometers, we will use the formula theta over 360 2 pi r. And what is theta? What is theta? How do we get our theta? Our theta is always the difference in latitude. When it is along a small circle, along a great circle, the theta is always the difference in latitude. If you look here, we have this latitude north and latitude of this one south. What do? When we have latitudes of different sides, like this is the northern side and this one is the southern side, what do we do to get the theta? At that point, theta will always be gotten by addition of the two, because they are in different sides. Addition of the two, we add the two, that is 40 degrees plus 20.5 degrees. What is that? The theta is here is 60.5 degrees. Now, to get now the distance in kilometers, we'll have theta over 360, which is just 60.5 over 360 times 2 times 22 over 7 times r, which is 63.7. That one there will give us the distance in kilometers along that great circle. The distance in kilometers along that great circle, 60.5 over 360 times 2 times 22 over 7, then 22 over 7 times 6370. 360 by 360 by 7. Now you get that this distance is 6,728.94 kilometers. That distance in kilometers is that. But they want it again in nautical miles. They want it again in nautical miles. There is a relationship between kilometers and nautical miles. You can say that one nautical mile is equal to 1.853 kilometers. Or you can go direct and get in nautical miles that you get distance in nautical mile is theta by 60. Now you can use any, because we have the distance in kilometers, you can change it to nautical miles. Or you can just take theta by 60 to get the distance in what? In nautical miles. Now the theta mile, let me just use it. See, my theta is 60.5 times 60. 60.5 times 60. What is that? 60.5 times 60. That is 3630. That is 3630 nautical miles. Now, that is how we get the distances. You find that, first of all, we get the difference. If you look here, the difference is a latitude difference, because we have two different latitudes. The distance is along a longitude. That means there is the difference is in the what? Is in the latitude. Now, first of all, you get that latitude difference to get your theta. Then then you use that formula of theta over 360 2 pi r to get your distance in kilometers when it's along a great circle. Then you use theta by 60 to get your distance in nautical miles when it is along a small circle. Then the next one, find the distance in kilometers and nautical miles between P. Let me give another example. Let me give another example. Let me give another example. Another example. Let me give another example. Another example. Find the distance in kilometers between. Find the distance in kilometers between. Find the distance in kilometers between point A, which is 0, 30 degrees east, 0, 30 degrees east. The distance between that one, 0, 30 degrees east, 30 degrees east. Then and B 0, 50 degrees east, 0, 50 degrees east. In kilometers and nautical miles. In kilometers and nautical miles. Now we have two positions along the equator, because this is the latitude. This is the latitude. Latitude is 0. Latitude is 0. That means it is along the equator. But I said that the distances along the equator and along all longitudes are to be in a great circle. Now this is equator, meaning the distances we are going to get at this point is along the great circle. And then the difference here is what? Is in the longitude difference. Now the first thing, we need to get the longitude difference at that point. Longitude difference at that point, all of them are on eastern side. All of them are on eastern side. Therefore, we subtract them. That is 50 minus 30 degrees. Now we find at that point is 20 degrees difference. Then to get the distance in kilometers now is theta over 360 2 pi r. That is 20 over 360 times 2 times 22 over 7 times r is 3. Now what is that? 20 over 360, that is 20 by 2 by 22 by 6370. Divided by 360 by 7. Now that is 2,224.44 kilometers. Then we have to change that one because they want the distance again into nautical miles. I can say theta times 60 to get the distance in nautical miles, or I can change this one here using the relationship that 1 nautical mile is equal to 1.853 kilometers. I can use that relationship, or I can just multiply direct. Now theta by 60, that is 20 times 60. What is that? 20 by 60, that is 20 by 60, that is 12. 20 by 60. 20 by 60. That is 1200. I mean that is 1200 nautical miles. Now you can see. Now, just as I said that distances along the equator are on a great circle. Now you consider the distances along the equator as a great circle. Distances along all the meridians or all along the longitudes are said to be on a great circle also. Now the way you calculate the distance along the equator is the same way you calculate the distance along the meridians. But we are going to get another example where we calculate the distances along the small circles or along other latitudes apart from the equator. Like, for example, find the distance. Another example. Find the distance in kilometers and nautical miles between point P, 30 degrees north, 45 degrees. Now, I have that now. Another example, that find the distance between point P, between P, which is 30 degrees north, 45 degrees east, and 30 degrees north, that is another point, 30 degrees north and 60 degrees west. 60 degrees west. I have those 2 points, P and Q. I want to find the distance along PQ. I want to find that distance. If you look at this, it is now along a given latitude, which is 30 degrees east. If you can draw the globe, let us draw the globe for us to see. If you can draw the globe, I have this is the prime meridian, this is the equator. Now here is a latitude 30 degrees north, I say 30 degrees north there, then 45 degrees east. I have 45 degrees east here. Degrees east. Now that is the point P. This is my point P. Then I have another point Q, which is on the same 30 degrees north but 60 degrees west. 30 degrees north but 60 degrees west. Meaning it is here. 30 degrees north, then 60 degrees west, meaning that point Q is at this point. When I have that 60 degrees west, this point Q. Now I need a distance at this point between P and Q, this distance here. If you look, that distance is along this, the distance is found along the latitude of 30 degrees north, of which this latitude, if you look at the radius of this latitude here, all of this latitude here is smaller than that of the Earth. That means when we need to get this distance here in kilometers, we use theta over 360 to pi r cos alpha. Now that's where we know where the alpha comes from. The alpha is always the constant angle. Alpha is always the constant angle. If you look here, there is an angle which does not change, like the 30 degrees north, 30 degrees north. That doesn't change. That is where we use our alpha when it is in the small circle. In small circle is where we use this alpha here, and the alpha is the angle which doesn't work, which doesn't change, like 30 degrees, 30 degrees. Then the theta is the difference, like 60 degrees west, the difference between 45 degrees east and 60 degrees what? West. Now let's get the theta first. Theta, if this is west, this is east. We want to get that. We want to get the difference there. 60 west, when it is in different sides we add. That means this is west, this is east, we add them. Now that is 45 degrees plus 60 degrees. I found that one to be 105 degrees. Now the difference there is 105 degrees. Now to get the distance now will be theta, which is 105 degrees over 360 times 2 times 22 over 7 times 6370 cos alpha, and alpha is 30. Cos 30. Now, this part here, 6370 cos alpha, is always to be the same as r. This area is the r radius of the small circle, that radius of the small circle. If you calculate all this here, will give you the radius of that small circle. Now, can we get that r first? Getting that r first, that is 6370 cos 30. 6370 cos 30. What do we get? 6370 cos 30. 6370 cos 30. I get something like 5,516.58. If you look at this radius here, is smaller than the radius of the earth that we have. The radius of the earth, that is with the earth, is 6370. But if you look at the radius I'm now getting is 5,516. But this is 6,370. That means this radius is less than this one here. Now that is where we get the small circle. Now we want to find the distance now. Let's find the distance now. The distance is 3/360 times 2 times 22 over 7 times 6370 equals 30. Now but 6370 equals 30 is this. Now I can just say 105 times 20 times 2 times 22 times this divided by 360 by 7. Now let me get that. 105 times 2 times 22 times answer is that. Then divided by 360 by 7. I get the distance at this point to be 10,113.73 kilometers. That is the distance between those points. 10,113.73 kilometers. That is in kilometers. Then I want to get a nautical miles. In nautical miles, it says that distance in nautical miles, you can change this one because this one in kilometers. You can do the relationships if I say that one nautical mile is equal to 1.853 kilometers. Or you can use a formula to get a direct theta times 60 cos alpha. And I said I have told you what is alpha. Alpha is the constant angle here. Now you can say that it is theta, which we have to be 105 times 60 cos 30. Now what is 60 cos 30? 60 cos 30. That is 51.96 by 105. 51.96 times 105. I get that answer to be 5,455.96 nautical miles. Now that is how we calculate the distances along the small circle, and as I say, the small circles are always found along the latitudes, of which this latitude must not be equator, because equator is considered to be a great circle. Then the next part we're going to talk about on this is called the speed on the earth's surface. Speed on the earth's surface. Speed. Because we've talked about distances. Now we want to talk about the speed. The speed. Now, we can have two different speeds. On the Earth's surface, we can have different speeds. One, we have knots, and two, we have kilometers per hour. What is knots? Knot is always in nautical miles per hour. Then kilometers per hour is just that kilometers divided by hour. And you know that the speed is always distance all over time. Now when we have to get the distance in knots, we have to get the distance in nautical miles, then divide by the time that you have. But when you have to get the distance in kilometers, when you have to get the speed in kilometers per hour, you will get your distance in kilometers, then you divide by time given. Now knots. The only distance I've introduced here that maybe someone doesn't know is knots. Knots is just the same as nautical miles per hour. As we were calculating the distances in nautical miles, now that nautical miles you found per hour is what we call knots. Then the kilometers per hour, you know, you've interacted with them very many times. Like you have a distance in kilometers, then you change it. You have a given time in hours, then change it kilometers per hour. That is what we are going to do here. Now there we will deal with an example. We'll deal with an example that an object moves from, we have an object is moving, an object, I don't know which object is this. An object moves from point P from point P, which is given to be 30.5 degrees north, comma 0 degrees to point Q, which is given by 30.5 degrees north, comma 45 degrees east. Find this in 3 hours. It takes 3 hours. In 3 hours, full stop. Then find the speed in kilometers per hour. Find the speed in 1 kilometers per hour, then 2 knots. Want to find those. Now, first thing, solution. Let us find the speed in kilometers per hour. Now, the speed is always given in distance followed by time. Getting the distance, we must calculate the distance because we are given positions. We must calculate the distances. But if you look at this, it is along a small circle because it is along a latitude of 30.5 degrees north, meaning it is along a small circle. Now at that point, we get what we call the longitude difference. What is the longitude difference at that point? Longitude difference at that point is, because this is 0, then 45. Now that longitude can be 0 plus 45 or 0 minus 45. I mean 0 plus 45 or 45 minus 0. That means it is 45 degrees. That is the difference. Then we need to get the distance. Distance in kilometers is theta over 360 times theta over 360 by r cos alpha. Theta over 360 pi r cos alpha. What is the theta? Theta is the difference, which is 45 over 360 times 22 over 7, I mean 2, that is 2 pi r, times 2 times 22 over 7 times 6370 cos alpha I said to be the constant angle. What is the constant angle? 30.5, I mean 30.5. Now let's get that distance in kilometers. 45 times 2 times 22 times 6370 cos 30.5 divided by 360 by 7. Now I find that one in kilometers is 4,312.45 kilometers. Now I have that distance. But I need to get the speed in kilometers. I have that distance in kilometers. I need to get the speed in kilometers per hour. What do I do? You know that I have the distance. The distance is 4,312.45. Then I need to get the speed now. I need now to get the speed. The speed, as I said, speed is equal to distance over time. Now the distance there is 4,312.45 all over the time, which is 3 hours. All over 3 hours. This is the time, which is 3 hours. This is the kilometer. What is that? I get the speed is 1,437.48 kilometers per hour. Now that is the speed. Then they again ask to get the speed in nautical, miles per hour or knots. Now the speed in knots there. I have to get the distance in nautical miles, which is theta by 60 cos alpha. What is theta? Theta I found to be 45 by 60 cos 30.5 cos 30.5. That is 60. 45 by 60 cos 30.5, I mean, cos 30.5. I found now that distance is 2,326.40 nautical miles. I have that one. Then I need now the speed. The speed now I know it is distance all over time. This is the distance. Then all over time, which is 3 hours. What is that? That is 775.47 nautical miles per hour, or knots. Or knots. That is how we get the distance, the speed. Now the speed, just as I say, the speed in knots is the nautical miles per hour. Then the speed in kilometers per hour is just that kilometers divided by time that we have. Then the next part we're going to discuss again after. I have another example that I'm going to discuss. Another example under speeds. Another example under speeds that let us discuss. Another example under speeds that we will discuss. Another example. An aeroplane leaves point A. An aeroplane leaves point A, which is given by 40 degrees north for 78 degrees west. 40 degrees north, 78 degrees west. And flies due west. And flies due west. And flies due west. And flies due west at 600 kilometers per hour. At 600 kilometers per hour. If it travels for 3 hours 20 minutes. If it travels for 3 hours 20 minutes. How far, part A, how far has it traveled? How far has it traveled? How far has it traveled? Then part B, what is the position? What is the position of the next point? Part B, what is the position of the next point? What is the position of the next point? A very good example now. Now, an airplane leaves point A, which is 40 degrees north, 78 degrees west, and flies due west at 600 kilometers per hour. If it travels for 3 hours 20 minutes, how far has it traveled? Now, how far? How far? They are asking the distance. We have the speed and we have the time. Now we have to get the what? The distance. Now solution of part A. Solution A. Now we have the speed. We have to get the distance. Distance is always given as the speed times time taken. Now what is the time taken here? 20 minutes, that is a third. A third, 3 and a third. Now the time at that point is 3 and 1 over 3. That is just 9, 10. 10 over 3. It has taken 10 over 3 hours. 10 over 3 hours times speed times time, which is times the speed, which is 600 kilometers per hour. What is that? 10 over 3 times 600. meaning the distance traveled is 2000. The aeroplane has traveled a distance of 2,000 kilometers. Then the next part, they need the position. They need the position. Look, it is very important to understand what is happening here. Let's first draw the globe and see. Let's start by drawing the globe and see what is happening. And see what is happening here. We are told that an aeroplane starts at point A. An aeroplane starts at point A, and point A is 40 degrees north. Now this is my latitude 40 degrees north, and 78 degrees west. Now this is my 78 degrees west. This is 78 degrees west. That meaning it starts at this point and flies due west, meaning it is flying due west, meaning there is no change in latitude. There is no change in this latitude, but it flies due west. It goes due west. It flies due west. There is no change in latitude, but it will change a lot, a longitude at that point. Due west. It goes due west. Now, that position, we want to calculate this position. To know that, why am I bringing this? I want to know that this distance this aeroplane has covered, is it along a great circle or along the small circle? But if you look at this my diagram now, as it flies due west, that means the distance it covers is along the small circle. No change in the latitude. Even to the next position, there is no change in the latitude. Latitude remains to be 40 degrees north. But there is a change in the what? In the longitude. And that is what we want to find, that change in longitude for us to get the position. Now, we have the distance. But this distance covered here is in a small circle, which is equal to this distance here. Now, to get this distance here, we will use theta over 360 2 pi r cos alpha, and which is equal to 2000. This one here is equal to 2000 kilometers. But you have all this apart from the theta, because we want to find that theta. We have all that. We have everything apart from this theta. We want to find this theta here. Let us now put everything into our formula. We find that the distance is theta, which I don't know, over 360 times 2 times 22 over 7 times 6370 cos alpha. And the alpha is said to be the constant angle because it is not changing the latitude, meaning the latitude is the constant, which is 40 there. Which is 40 there. Now, all of this, if you calculate all of this, will give me theta. Theta times this, times this, times this, times this. That is theta by 22. Now I can just say 2 by 22 by 22, 2 by 22 by... Okay, and this one here, all of this here is equal to 2000 kilometers. All of this here is equal to 2000 kilometers. Now I have 2 times 22 times 6370 times 6370 cos 40. 2 times 22 times 6370 cos 40. Now I find that this is 214 706.93 theta, and this one is over 360 by 7 over 2520 is equal to 2000 kilometers. Now let me divide this one here by this first. 214 706.93 divided by that. I have 80 0.2 theta is equal to 2000. Now to get theta, I divide by 85.2. I divide by 85.2. What is that? 2000 divided by 85.2. 2000 divided by 85.2. That's the theta here. Theta here is 23.47 degrees. Now, in the 90 division, this go with this. Now I have remained with theta is equal to 2000 divided by 85.2. Now this one divided by 85.2 gives me this. Now theta is equal to 23.47 degrees. Now I have that one to be my theta. Now to get the position, now I need to get this position. That is theta. And theta, I say that theta is always the change. Is always the change. At this point, there is a change in longitude from, if you look here, there is a change in longitude from 78 degrees west to another point where the difference is 23.47, and it is moving due west. That means to get this position, this longitude here. Now the longitude of that position will be 78 degrees plus, because it goes due west, plus 23.47, and this one is degrees west. It goes to further, it continues to go to west. That is, we add them. Now 78 plus 23.47. Now the longitude of that point will be 78 degrees plus 23.47 degrees west. Now what is that? If I add 78 plus 23 plus 23.47, I get, it is 101, it is 101.47 degrees west. Now this is the longitude now, but they want what is called the position. They want the position of that point. The position, first I say that the position is given in latitude, longitude, coordinate system. Now, what is the latitude? Latitude does not change at this point. That means the latitude is 40 degrees north, the longitude I found, which is 101.47 degrees west. And that is the position of the point that the aeroplane is going to. And that is the position of that point that the aeroplane is going to. And that is the end of that example. Then the next part, which can be considered as the last part of this topic, is longitude and time. Longitude and time. Longitude and time. And that is the next part. The second last part of this topic is longitude and time. 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 As I have just said that longitude and time. In longitude and time, we deal with only two things: longitude itself and the time. There is nothing we don't consider on the latitude. The change in time is brought about by the change in longitude. Now to do that, we only consider the longitude. To calculate times, we only consider the longitude. Now we have that subheading, longitude and time. Now, the thing you have to know is that one change in degree brings about 4 minutes change. One change in degree brings about 4 minutes change. All 15 change in degree gives about 1 hour change. That means the places which are 15 degrees apart have difference in time, which is in 1 hour. 1 hour difference in time. Places which are 1 degree apart, they experience different time, which is 4 minutes. They experience different time, which is 4 minutes. But what you have to know that the time which are found in the eastern side, times in the eastern side are always higher or earlier than the time in western side. Now when you have two places, which one is the western side of the other, know that that time we'll find is somehow lower than the time which is found in the eastern side. Now for example, the example I want to deal with here is the local time. I'm told that if the local time in London, 52 degrees north, 0 degrees, 52 degrees north, 0 degrees, that is the position of London, 0 degrees, is 12:00 noon. Is 12:00 noon, comma. Find the local time at Nairobi. Find the local time at Nairobi, which is 1 degree south, comma, 37 degrees east. I want to find that time. We are told that the time in London, London is found at longitude 52 degrees north, 0 degrees, that is along the prime meridian. Then is 12 noon. The time in London is 12 noon. Then we should find the time in Nairobi, which is in 1 degree south, 37 degrees east. We want to find that time in Nairobi. Now what do we do first? We have to know what is called the longitude difference, because I said that the time deals with the longitude alone. If you look at this point, even this and this are different. But to calculate the time, the only thing that we will deal with is the longitude difference alone. What is that? To find the longitude difference there, that is 0 and this is 37. The difference there is just 37 degrees. But when they are in different sides, we will add. In the same side, we will subtract. That's the same we were doing previously. But at this point, this is 0 and this is 37. That means the difference is just 37. That is difference in degrees in longitude between London and Nairobi. Now we want now to find the difference in time. Difference in time between London and Nairobi. Difference in time that we found that if 1 degree is equal to 4 minutes, then we want to find how many minutes are there. 37 degrees is equal to what? That is 37 by 4. What do we get? When we multiply 37 by 4, what do we get? 37 by 4. We get it is 148 minutes. Meaning the difference there is 148 minutes. I have 148 minutes. That is the difference in time. Difference in time in those two places, Nairobi and London. But let us change it into hours. That this in minutes. Now let us divide by 60. Let's divide by 60. When we divide by 60, it will be 2 hours. 120, that is 2 hours. Remaining here is 28 minutes. 2 hours, 28 minutes. When I divide this 120 will give me 2 hours. Then the remaining one is 28 minutes. Now there is 2 hours, 28 minutes here. Meaning the difference in time between Nairobi and London is 2 hours, 28 minutes. But we need to find the time in Nairobi. We need to find the time in Nairobi, which is 37 degrees east. Now let us consider, this is 0 degrees. And this is 37 degrees east. Let us consider, we need to know which one is in the eastern side of the other. Which one is in the eastern side of the other? Let us draw the globe just to see what is happening. This London is found for 52 degrees north. Now this is 52 degrees north. If this is the equator, 52 degrees north and 0 here. Then Nairobi is found at 37 degrees. 1 degree south. 1 degree south is somewhere here. This is 1 degree south. And the longitude here is at 37 degrees east. And this is my Nairobi. This is my Nairobi. Now we need to know which one is in the eastern side of the other. Between London and Nairobi. This is London and this is my Nairobi. You need to know which one is in the eastern side of the other. If you look, Nairobi is in the far east of the London. That means the time that will be experienced by Nairobi is higher than the time in what? In London. Now what do we do there to get the time in Nairobi now? Because we have given the time in London, which we have now known that the time in London is lower than that one of Nairobi by what? By 2 hours 28 minutes. Now to get the time in Nairobi, we take the time in London, add to the difference the time there. Now that is 12:00 noon plus 2 hours 28 minutes. I get that one to be 14:28 hours, which just 2:28 p.m. And that is the time in Nairobi, 2:28 p.m. And that is all about the longitude and time. That is all about longitude and time. Now the last thing we are going to discuss, is the shortest distance along the Earth surface. Shortest distance along the Earth surface. The shortest distance along the Earth surface. Shortest distance along the Earth surface. Shortest distance along the Earth surface. Now, the shortest distance along the Earth surface are always the distances along the Great Circle towards the pole. There are always distances along the Great Circles towards the pole. For example, if I have a distance in latitude, you consider towards the pole. Now the distance in latitude, you will find that if you have a latitude, this latitude here, the distance along the latitude, and it makes a given degrees here to the, center of the Earth. And let me just use this. It makes a given degrees here to the center of the Earth. There is degrees. It makes, for example, this is now the equator. It makes a given degree here. This is the degrees we measure. This one here. Let me say it makes a given 37 degrees to the equator. If it makes this 37 degrees to the equator, this means here also is 37 degrees. But the shortest distance is always to the pole, to the North Pole, or to the North Pole or to the South Pole, which is considered to be the distance along the Great Circle. Now, to get this shortest distance, we'll get something called shortest distance in kilometers is always it's always 180, which is all this angle 180 minus 2 alpha, because the alpha is said to be the common angle. Usually here is 37, here is 37. Now the alpha is always the common angle, 2 alpha over 360 times 2 pi r times 2 pi r. Now theta over 360, it's just theta over 360 2 pi r, but because we have this one here as an alpha here and this one is another alpha here, now we subtract the 2 alpha. Now 180 minus 2 alpha over 360 times 2 pi what? Pi r. For example, we want to find the distance which is made by this one, which is made by the shortest distance which is made by that one. Now I have 180 times 37 by 2 times 37 by 2, which is 74. 180 minus 74, I mean minus 74 over 360 times 2 times 22 over 7 times r, which is 63, 70. And then that is how we get the distances, the shortest distance. The formula is this: 180 minus 2 alpha over 360 2 pi r. Now do I have an example? Now let me just use any example somewhere that I have. Any example somewhere that find find any example I have that find the shortest distance. Find the shortest distance. Find the shortest distance on the Earth's surface from point P 30 degrees north, from point P 30 degrees north, 45 degrees east, and Q and Q, P and Q, which is 30 degrees north, and 60 degrees west. 60 degrees west. Now we need to find that shortest distance, and I've said that the shortest distance is equal to 180 minus alpha 2 alpha all over 360 times 2 pi r. And what is the alpha? Alpha, as I defined it, alpha is always this constant angle there. Now it means that the shortest distance at that point is 180 minus 2 alpha, that is 60, minus 60 over 360 times 2 times 22 over 7 times 63, 7. Then 180 minus 60, that is 180 minus 60, that is 120. Now have 120 over 360 times 2 times 22 over 7 times 63, 7. What is that? 120 divided by 360. 120 times 2 times 22 times 63, 70. Also divided by 360 by 7. Divided by 360 by 7. Now you find that the shortest distance covered at this point is 13,346.67 kilometers. That is the shortest distance. Now to find the shortest distance is always 180 minus 2 alpha over 360 times 2 pi r. And r of the earth is always 63, 7, as you know. And that is the end of that topic. Everything considered discussed. Thank you.